Hello, everyone. Thanks a lot for coming to my session. So I was strongly considering wearing my Springboks jersey because I'm from South Africa, but I thought that might ruin the cloud-native camaraderie. I can actually already see someone shaking their head. So I guess I chose wisely, especially for my session. Out of curiosity, any rugby fans here? Yeah, I'm definitely in the minority. All right, well, we're all together in the cloud-native context, right? So the title for this session is Secure Workloads Know Who They Are: Attestation, Restriction, and Enforcement in Kubernetes and Beyond. My name is Lukonde, and I'm a Senior Developer Advocate for Kubernetes at AWS. I'm also a CNCF Ambassador. And if any of you want to connect with me, please feel free to do so via LinkedIn. You're also welcome to subscribe to my YouTube channel for those of you that are interested in watching cloud-native content. I'd also encourage you to check out the AWS container-specific YouTube channel called Containers from the Couch. Now, to more important things. I thought I'd start off with a story that some of you might resonate with. A couple of years ago, I was part of a team that was rolling out a new digital product to the cloud. And this particular product had a lot of integrations with on-prem services. Now, I thoroughly enjoyed my time working on that particular project, but there are a couple of things that are still hard or unpleasant to look back on. But I choose to hold on to the memories of them because they serve as motivation for various initiatives, like this particular topic. Now, on one particular evening, this is well past the hour of dinner, but several hours before breakfast, we were up rolling out a new version of this application, as well as testing it. And unfortunately, things weren't going well. Some of you might relate to that. We found ourselves in somewhat of a treasure hunt, and that's putting it in positive light. The treasure in this case was getting the expected responses for the API calls that were being made from services in the cloud to on-prem systems. And so what the night kind of looked like was we were getting a lot of errors, and so we would engage with the different folks and owners from the different subsystems, and we'd ask them, hey, we need your assistance, or we're not too sure why we're getting this particular error. And a person from system B would help us out, and we'd resolve the issue between our system and theirs, which was a yay moment. But then we encountered another error. And so we followed a similar route. We got in touch with additional folks from the next system, and they helped us out again. Now, a lot of times in the midst of all of this, we had folks telling us, actually, you don't have the required token for this particular request to be handled rightly. You need to fetch that token from this other system. So we had a lot of fun on that night. Eventually, we did get our treasure, which is good news. But one of the reasons I hold on to this particular memory is because I believe that the story is a portrait for a present-day problem. Not for all contexts, but certainly in some. A lot of modern systems are complex and convoluted. They consist of so many different services, sometimes in a single cloud environment, sometimes hybrid, and they're very distributed and heterogeneous. And this isn't going away anytime soon. And so one of the reasons this isn't going anywhere is due to a couple of different reasons. One of them is microservices. This is a usual suspect for a lot of things. We still love microservices. But the reason why microservices are a contributing factor is because they're single-purpose modular elements that have independent lifecycles, very easy to integrate into a larger system when you have increasing requirements. So it's fairly easy to add another service in some kind of disparate environment, as long as it's able to communicate with the other services when necessary. Another contributing factor is the fact that teams have their services distributed across the cloud and on-prem. A hybrid cloud model is still a very popular one. Some companies opt to have their services spread across different cloud environments. But then also, in some organizations, within the same company, different business units have their own applications with independent lifecycles, and depending on the objectives that they have, some of those services need to integrate for a specific purpose. Some of you might relate to this as well. And in some cases, those integrations may exist across entirely different organizations. On and on it goes. Now, at a micro level, these interconnections look relatively straightforward. But when you take a step back, at a macro level, you have a web of complexity. And Again, this isn't going away anytime soon because the main objective is a lot of companies and teams are focused on enhancing their digital products, which is not a bad thing. If you think of some of your favorite mobile, web, or gaming apps, a lot of them consist of various integrations that create a larger ecosystem beyond the walls of a single application. So that's something that's going to continue to happen, but it will also come with the implication of additional integrations. So the modern system, in many ways, is very distributed and heterogeneous in nature. But I want to focus on the major security implication of this. Now that we have services spread across the board in different environments with their own life cycles, their own standardizations, you have to consider more and more, how do your workloads know who they are talking to? How can you be sure that they're engaging with the right peer and that the peer is able to validate a client and that the client is able to validate the server as well? How can you be sure that the messages are concealed in the right way so that in the case that a third party intercepts any of those messages, the messages would be protected from sensitive information being captured or decrypted in any kind of way? These are the things that you have to consider all the more now because of this large web of complexity. All of a sudden, network calls are going beyond the walls of a single environment and traversing all sorts of other networks that are outside of your control and other subsystems. So the traditional virtual perimeters are no longer sufficient. So you have to ask the question, how do you solve this particular challenge? Now, one might say, well, how about we just take the existing security identity models in each of these applications or microservices environments and put them together. We bridge them. Well, that can work, but it's not that straightforward. In fact, one of the big challenges that we faced in the story that I shared earlier was trying to accomplish this. We were trying to bridge multiple security identity models, and it resulted in several errors. So, not to say that it's impossible, but it's certainly challenging, and in many cases it results in the following issues. Raise your hand if you love meetings. Oh, great, we got one person. Oh, you're not alone, I'm with you. But it's a T-Rex raise. Okay, so my hand's only here. So usually this results in lots of meetings between platform, security, DevOps engineers, application developers, trying to make sure that there is alignment between the different security identity models and that there's a good understanding of the threat modeling across the board. But not only that, in a lot of cases, application developers have to continuously modify their respective services to cater to the different services that they are integrating with. So the juggling of the different security identity models. In addition to that, this kind of approach increases the chances of security misconfigurations. Again, that's a ditch that we landed in because it's hard to always cover your bases the right way when you're juggling multiple services. Now, in a small scope, this might not be much of a challenge, but if you're dealing with the kind of problem that I'm describing here in terms of wide distribution, lots of heterogeneity that is increasingly growing, then this becomes more likely. Or you have the other approach that some engineers take. And I'm not going to ask you to raise your hand, but I've certainly heard this response a whole lot, especially this year. The problem is so complex, so we're deferring that for later. They choose to kick the can down the road. Now, the problem with kicking this particular can down the road is it gets bigger and heavier the more that you kick it. Because if your system is continuing to grow because of the desired enhancements, then that means there's more complexity and a bigger size, but that aligns with the requirements that are necessary to secure it. Even though you're not addressing it there and then, the requirement to secure your system is increasing in complexity and size. So those are some serious things that you have to think about. And that brings us to a big question, right? How do you secure workloads and their interactions in a large web of complexity? And I want to walk through making use of a standard mechanism for identity issuance and attestation. And this is going to be a majority of the session. I will still speak about restriction and enforcement, but this is the key foundation. Reason being is having a single or universal standard that cuts across the web of complexity is going to alleviate a lot of the risks that are tied to juggling multiple security identity models. In addition to that, If you have this universal standard across the board, then it creates the kind of foundation that allows you for further digital enhancements. Because as I mentioned earlier, that's not going away, and we don't necessarily want companies or teams to be inhibited from advancements and adopting new services that get integrated into the web of complexity. But we do want to make sure that how things scale is done in such a way that it is building on a certain security model that will support the overall objectives. Now, what does it mean to have a single identity standard in a large web of complexity? So by a single identity standard, I'm referring to the method, approach, or mechanism by which workloads are first attested and validated before they receive any kind of digital ID, proof of that ID, and are then allowed to securely communicate with other services. So if you take a look at this diagram over here, everything should essentially start off with 0 or no implicit trust whatsoever. And only after it has been securely attested can it then receive the relevant identity and be allowed to be part of what you could call your trust domain or your domain of trust. Now, you might be wondering, well, what exactly does attestation look like? Well, it's not that different from the real world. When I went to get my national ID, I had to avail myself, I had to present certain information, proof of that information, and I was also interviewed. Now, there was a specific set of characteristics or criteria that the relevant authority was interested in. They didn't care much for my dog or my dog's name or the school that I was going to or what my hobbies were. There were specific details that they wanted. And we can translate that to the digital space as well. We can have pre-configured or predetermined characteristics or a criteria that we use to test a workload and whether or not it should be in our domain of trust on the far right over there. Well, this should be, yes, your far right, my left. All right, so when you follow that particular process, that will allow you to start building what is a key objective, this domain of trust. Remember, we're starting from a place of 0 or no implicit trust and eventually working your way to a place at which you know that anything that's a part of that particular domain is something that has gone through the attestation process. Now, I want to explore this a little bit further. I find that this particular analogy helps a lot of folks that are trying to wrap their heads around this. I remember when I worked for a particular consulting firm, they issued me a company card. This is something that I imagine most of you can probably relate to. And that particular company card gave me access to that building. Now, while I was consulting at that firm, or rather while I worked for that consulting firm, I was consulting at the same financial institution that I was referring to earlier. But when I showed up at that financial institution, the company card I had from the consulting firm did not work. Anyone else experience that? I expect you're a lot smarter than me and you didn't even bother because you know that's not going to work. It's two different trust domains, right? And so that's the same concept here as well. I had to be attested, essentially, and then received a new company card from that separate firm. And if I happened to be interacting with 4 or 5 other firms, not that I would do that, I would have probably received a separate company card from each one of those. And that kind of approach is akin to a single microservice having to juggle separate security identity models. And what's more desirable is to have something that is similar to the passport system. Now, I only have one passport, and I use that same passport for the different foreign nations that I go to. And each foreign nation essentially functions like a trust domain. And there is a bridge of trust between those different foreign nations and my country of origin. But I don't have to juggle multiple documents. I only use a single passport. Now, this is something that can also be translated to the software space. Having a single standard that can be used across the web of complexity. And you can accomplish that using SPIFFE. Raise your hand if you've heard of SPIFFE. Pretty sure most hands will probably go up here. Keep your hand up if you have used SPIFFE or implemented it in any kind of way. Okay, a lot less people. Cool. So SPIFFE stands for Secure Production Identity Framework for Everyone. It's an open source technology that consists of specifications or standards that allow you to have universal issuance of digital identities as well as attestation of those particular identities. And a great thing well, one of the great things about SPIFFE is you can implement a single standard or API. And so that means that all the workloads across the board can be using the same standard. Not the same criteria, but by standard, like I mentioned earlier, the same mechanism by which workloads are attested and then receive an identity. And in addition to that, it's interoperable. So this is not just restricted to your Kubernetes environments. Some of you might even relate to this as well. If you're running a system that doesn't just consist of a Kubernetes cluster, but integrates with other services, whether it's on-prem or a different cloud environment, do you mind just raising your hand? Oh, so just a few folks. Oh, most of the people are doing T-Rex raises, but I see that there are a couple of people with that. So, and the point there is just the fact that Kubernetes is not the only place to run your workloads, and that there are a lot of contexts where workloads in Kubernetes will be integrating with services outside of that. And so we still want to maintain the right secure approach when it comes to this large web of complexity, and having a single thread or standard that can cut across them, whether your workloads are running in Kubernetes or running in virtual machines outside of a cluster, in the cloud or on-prem, or perhaps even cloud functions. A big win for engineers as well is the fact that they'd be using a standard API as opposed to juggling multiple identity models. And you can choose the implementation that you want to go with. There are native libraries that you can encode into your specific applications. Alternatively, you can adopt a sidecar model where that's decoupled from the application source code itself. And I'll be demonstrating that a little bit later. Now, another key aspect is setting up trust domains, like I walked through earlier. And so a trust domain is essentially the scope in which workloads that have been attested and received IDs exist. But just because they exist within that trust domain, it doesn't mean that there's never any validation that takes place after that. For every single workload that exists within that trust domain, it will receive what is known as a trust bundle. The trust bundle is basically a set of information, like public certificates, that are used to validate any peers that want to communicate. And so it's an ongoing process as well in terms of the continuous validation. And depending on your context, you can either have a single root of trust, or you can have multiple roots of trust. And when you have multiple roots of trust, that's essentially called SPIFFE federation. So you bridge trust between the two different trust domains. And so when you follow that approach, the two roots of trust essentially exchange the SPIFFE trust bundles so that a workload in trust domain A can use the trust bundle from the foreign trust domain to validate a workload from trust domain B. So very similar to the passport-like system where you can essentially say, I have the relevant information from a foreign nation to validate this foreign national to see, is their document valid? And are they who they say they are? So just briefly, building on top of a universal security identity model, I want to touch on restriction and enforcement before I do a brief walkthrough of a demo. So you passed authentication or auth-n, which is good, but then the next step is authorization. There are multiple layers that have to be covered when it comes to security. It is not a single vector. And so following authorization mechanisms, I believe, is something that is a lot more dynamic as opposed to having a single standard for your authentication in a web of complexity. There are multiple mechanisms that you can make use of depending on the different environments. And before I get into some of the examples, which I'm sure most of you are already familiar with, I'll use the same example of working at a consulting firm. So when I did get the company card from the financial institution, I had general access to the building. But here's another one. Any of you have a company card that allows you to just get main entrance access, but then on one occasion you tried to access a particular room or floor and it just didn't work? That ever happened to anyone? I see a couple of hands. I suppose the real question is, what were you trying to do in that floor? No, I'm kidding. So that's something that just kind of demonstrates what I'm essentially speaking about over here. It's that access control layer. Just because you are known and trusted to some degree, it doesn't mean that you should have access to absolutely everything. And that's essentially what you would be applying even in your digital space. You can make use of CNI-based network policies to control the flow of network traffic so that certain workloads are able to communicate with other workloads, but that doesn't necessarily mean that they can carry out every kind of operation that exists. You can also make use of authorization policies based on a specific service mesh implementation, if that's what you're using in your environment. There's also attribute-based access control, role-based access control, and a lot of those are very specific to the Kubernetes context. But outside of that, even for virtual machines, you can continue to make use of your virtual firewalls, or making use of a web application firewall that you attach to an API gateway as well. But ensuring that you have this additional layer building on top of the universal security identity standard that you're using for authentication. Now, in addition to that, I also just want to speak briefly about policy enforcement with Open Policy Agent. And with Open Policy Agent, you can use Rego to define some very dynamic rules that are specific to the kinds of requests that should be allowed in your web of complexity. So over here, I have two blocks that might be a bit difficult for some of you to see, but essentially these are two allow rules that specify the kind of request that is permitted, but it also defines what the shape of the SPIFFE ID should be, or the specific SPIFFE ID. And so this starts narrowing down things a whole lot more, making your environment essentially more secure. All right, demo time. But before we get to that, I want to cover some of the architectural parts of the demo so that you have an idea of what's going on in the background before I walk through it. So over here, I have I call it a custom mesh, which is essentially what it is, but it's different microservices. You'll see on the left over here, I have an edge proxy, which is just an envoy proxy. So that's what receives the requests coming from outside of the environment. And it proxies those requests to a GraphQL API and two other microservices called orders and products. And each one of them is making use of the envoy proxy. The reason I'm making use of the envoy proxy over here is because I wanted to decouple the application source code from the particular SPIFFE configurations that I'm making use of in this environment. Now, you can implement the SPIFFE specifications and standards by yourself. Some of you might be familiar with the fact that Istio actually has, out the box, a SPIFFE specification that it uses for its SPIFFE verifiable identity documents, essentially the IDs that it issues out to any component that's part of the mesh. But you can also make use of SPIRE, which is essentially the production implementation of all those SPIFFE standards. Hence, me having it over here, and that's what I'm going to be making use of. And by default, it's got its own certificate authority, but you can also configure it to make use of an upstream authority, which is what I'm doing over there. And you can use other ones. You don't have to use ACM PCA. You can use Cert Manager or HashiCorp Vault. And I'm going to move on. In addition to that, I'm using the same SPIRE server as the same root of trust for an Istio service mesh. So I've installed Istio, but I made it a custom installation so that it would make use of the SPIRE server. So this is also just to show you an example of how you can use a single root of trust for different environments. Because you might have a team that, for whatever reason, is making use of a custom mesh like this, where they're essentially deploying their own sidecar proxies for every microservice, whereas you have another team that has just rolled out Istio instead. But you can make use of the same SPIRE server for both of these so that they're sharing the same root of trust, allowing you to have mutual authentication between the services in the Istio mesh and the custom mesh. So I want to show you some of the configurations specific to the orders API. Over here, you'll see that there's a blue arrow going in, first passing through the envoy proxy before getting to the orders API. That is essentially external requests that come either from the edge proxy or the GraphQL API. So those would be downstream requests coming from downstream headed up to the orders API. But also the orders API makes upstream requests to products, which you can see over there. And I know that is a lot of code, so I hope you can see the highlighted areas so you can ignore the rest of the noise. So in the top right corner, you'll see downstream TLS context. So this is referring to the configurations for requests coming from downstream. So this is for orders, so that means that this is requests coming from the envoy proxy and the GraphQL API. And so you'll see the yellow line over there that underlines require client certificate, because I'm setting up mutual authentication, meaning any downstream requests must be accompanied with a specific certificate. And then below that, I have the oval, side oval, that is pinkish, and it is circling the area where I've specified the SPIFFE ID associated with the certificate that the orders microservice is using. And then right at the bottom over here, I have this orange block. And in this orange block, I've specified the specific SPIFFE IDs that I expect to get associated with any certificate that comes from downstream. Because remember, we could get downstream services that do provide a certificate, but we're not just trying to trust any workload out there or any infrastructure component out there. So I've specified that I want the certificate to be associated with this particular SPIFFE ID, which is edge proxy service account at its suffix, and then the second one is associated with the GraphQL service account. So these are the specific SPIFFE IDs that I expect to get when I'm presented with certificates. Now over here is upstream. So you'll see in the top right corner, underlined there with the purple line over there, you'll see it says upstream context. So this is now orders reaching out to products. And so once again, I've highlighted the area that specifies the SPIFFE ID associated with orders certificate that it will be presenting to products. And then right at the bottom over here, because if you recall that diagram I showed, orders only ever communicates with one upstream server, and that's the products API. And so down there, I only have one SPIFFE ID that I expect to be associated with any certificate that will be presented upstream, or that will be presented from the upstream server, which is the products service account SPIFFE ID. Okay, demo time, but for real this time. So first off, I just want to show you an example of the Istio mesh and what's going on in there. So the Istio Ingress Gateway has received a SPIFFE ID and certificate from the same SPIRE server, and then you'll see that it is communicating with the orders service that is running inside of the Istio service mesh. And you'll notice that there are locks over there on the green lines just highlighting that this is a secure path. So there's mutual authentication taking place. And it's a bit small, and I wish there was a way I could expand that. I did try earlier, but it didn't work. But on the right side, you'll see there's MTLS enabled, and under principles, you'll see that there are actually SPIFFE IDs there for the client and the server involved in this particular request. Now over here, this is now the custom Envoy mesh. And so because everything is configured and set up correctly over here, when I make a request, and this particular request first reaches out to orders, and then after it successfully gets orders, it will then fetch products associated with those orders. If I hit play over here, oh, there we go. Not today. So I'm just going to scroll down slightly so you can see I got a successful request over here, orders with products associated with each of those products from the GraphQL API. And then next, oh, I accidentally closed one over there, but that's fine. Now over here, this is a request sent to the orders API and fetching products associated with those orders. So a request similar to the GraphQL query I just showed you, but this is directly to the orders API. And as you can see, this request is also successful. So in the background, there's mutual authentication between the edge proxy and the orders API, and then the orders API and the products API. But I fiddled around. Now that should not have closed, but I know the endpoint, so I will just quickly do this. Wouldn't it be fun if everything worked smoothly? Or maybe I'm just telling myself that to feel better. So I fiddled with the configurations between the edge proxy and the edge envoy proxy and the products API. So I purposefully misspelled the SPIFFE ID that should be associated with a particular certificate from products. And because of that, the edge proxy is not able to successfully communicate with the products API, and we get this error over here. Otherwise, if I just showed you successful responses, you could always ask the question, but Luke, can we really trust you? After all, it's a talk on trust, right? So you can see over here, upstream connect error, and you can see specifically certificate verify failed. So the verification failed because of that change that I made to the SPIFFE ID that should be associated with the particular certificate. And that brings things full circle. My time is up, so if any of you have any questions, I'd love to catch up with you afterwards. Thank you.